Good morning, students. Let's proceed our chapter magnetic effect of electric current. Till we have studied that when current is passes through a current carrying conductor, so magnetic field is produced around the conductor, and that is given by right hand thumb rule. Right hand thumb rule states that if the direction of the thumb of right hand indicates the direction of the current, then direction of all the curled fingers shows the direction of magnetic field produced around the conductor. Then what happens if this current carrying conductor is placed in external magnetic field? So let's start. I have taken horseshoe magnet. Again, students, you will think, why not we have taken U-shaped magnet, why we have taken horseshoe magnet. Horseshoe magnet, its poles are nearer, so it has more strength. In horseshoe magnet, in between, there is one conductor, say this, and this conductor is connected to a wire, and this wire is connected to a battery. As soon as we connect this one, current started flowing, and as the current started flowing, what we observe? We observe that this conductor comes downward. It comes downward. When you change this current, it will go upward. So like this, when it is flowing, it moves upward and downward like this. How this has happened? We have not done anything. We have only just passed the current. Then, as current passes, magnetic field is produced around the conductor, and this magnet have itself magnetic field. There is interaction of the two magnetic field which exerts force on the conductor, and then this conductor comes in motion. That force depends upon magnetic field B. If there is strong magnet, that means strong magnetic field, force exerted will be stronger or more. Again, force is directly proportional to current. Naturally, if more current will pass through the conductor, that means more strong magnetic field is produced, and that stronger magnetic field interact with the magnetic field of this magnet and exert more force. So, more force is produced. Again, it is directly proportional to theta. What is this theta? It is theta. Theta is the angle between B and I. This is angle between B and I. That is magnetic field and current. So here, first of all, I have told you theta. Now you have understood theta. So, force is directly proportional to sine of the angle of theta. So, it is sine theta. And it is also directly proportional to L, that is length of the conductor. Length of conductor. So, if we just write all this physical quantity in one, so we can write F is directly proportional to BIL sine theta. Students, whenever we are removing the proportionality in physics, we are adding one constant. So here constant we will write as K. So it is KBIL sine theta. That means K value is, here K value of K is 1. So, we will get BIL sine theta. We have got this as force. produced, and just now I have told you, if we change the directions of this terminal, then again direction of this force also changes. So this direction has been given by Fleming's left hand rule. What does Fleming's left hand rule says? Stretch forefinger, middle finger and thumb of your left hand like this, or you can say like this. Stretch forefinger, middle finger and thumb of your left hand in such a way that all the three fingers are mutually perpendicular to each other. Mutually perpendicular to each other, and that means it is perpendicular to all the three. एक दूसरे के साथ अगर हम देखेंगे, इसके साथ इसको, this is also perpendicular, this and this is also perpendicular, this and this is also. So whatever you will compare with all the three fingers, it is mutually perpendicular to each other. Full stop. If direction of the forefinger shows the direction of magnetic field and the direction of the middle finger shows the direction of current, then direction of the thumb shows the direction of force produced, which brings the conductor in motion. So how will you remember this? Very simple. FBI. F B I, and all the three are mutually perpendicular to each other. This is x-axis, this is y-axis and this is z-axis. So here only I have shown you what was the formula of that force. Force is equal to F BIL sin theta. That means when value of theta is 90 degree, then only sin theta is 1 and force produced is maximum. So when all these are perpendicular to each other, force produced is maximum. And this is used in motor. This is also known as motor rule. So sometimes in NCERT or your board based question it comes state motor rule. So don't get confused. State motor rule means state Fleming's left hand rule. It is used in motor. So what is the principle on which the motor works? So you have seen we have given a current I and magnetic field. Just now I have shown you we have taken a magnetic field and we have given a current to this conductor. Here what we have got, electric current is changes into mechanical energy, means electrical energy is changes into mechanical energy. So if the question will be asked on which principle motor works, so very simple in one line, electrical energy is converted into mechanical energy. What is the application of this motor rule? Very simple, that motor that takes the water from the pump or you can say ground and it just fill it up in syntax. So that is one of the application. Grinder we are using, that is mixie or for grinding, that is also motor rule. Then we are using washing machine, that is also motor rule. So many uses we are doing, or in many things it is applied, household applications. So students, motor only a little bit structure I am showing you, and then We will see how it is happening. So what we have taken? We have taken a motor magnet, north pole, south pole. We take one coil in between this. This is known as armature. इसको हम लोग आर्मेचर बोलते हैं. This handle is known as shaft. This is connected to slip ring. एक ring that is connected to slip ring, and this is connected to carbon brushes. Why carbon brushes? Then you will say that the carbon is bad conductor because diamond very bad conductor. But graphite is good conductor, but not so good conductor that we can use for applications. Here the current will pass in a controlled way. So that's why we have taken, this is known as slip ring. This is S1 and this is S2. This is carbon brush B1 and this is carbon brush B2. So as soon as you switch on, current started flowing, and as the current started flowing, it start rotating in the magnetic field. So magnet have magnetic field. This coil, as the current is passing through the coil, a magnetic field is produced in the coil, and when both are perpendicular to each other, then maximum force is produced, which we can feel and we are using for different purposes. So it rotates one full rotation. So this type of motor is known as AC motor. This slip ring helps the shaft to rotate, that means the coil armature to rotate the full rotation in between the magnetic field. So students, today up to here, next class we will do it. Okay.